Okay, we're looking at the problem again, comparing the percentage of TV ads that use humor between the United States and the United Kingdom. And I'm letting my population 1 be the TV ads in the United States. TV ads in the United Kingdom is the population 2 that I'm studying. The population parameters, the percentage of those that use humor, P1 being the percentage of TV ads in the United States that use humor, P2 being the percentage of TV ads in the United Kingdom that use humor. And I want, in this case, to run a hypothesis test on the difference between those population percentages. Samples were taken, and a sample percentage for the United States and one for the United Kingdom was calculated, and the difference is 11.1% or 0.111, and that is my estimate of P1 minus P2. Is it enough evidence to conclude that there is a difference in these population percentages? So in running a hypothesis test, the first thing I'll do is set up the null and alternative hypotheses, and I'm testing to see if I can show that there's a difference. The confidence interval that we did earlier is every indication that there is, but let's go ahead and run the hypothesis test and see if that is true. P1 minus P2, I'm trying to determine if there's a difference. So that would be my alternative, and I will assume that there is no difference, that the difference is 0. Second step of a hypothesis test is to determine the values I needed for the sampling distribution. I'm testing at 0 in the center. This is a proportions test at 5% alpha. I'm going to split that 0.025 on each end. And for standard normal, I remember that was a z-value of negative 1.96 critical value on the lower end and 1.96 critical value on the upper end. Next part of this is to get a standard error for the sampling distribution. And that is where we got to be careful here. We're going to look and see what formulas we need. Traditionally, of course, the sampling distribution is based on the null hypothesis being assumed true. In other words, we're putting the center at 0, and we need to calculate the variation. Notice that the null hypothesis also is saying that we're assuming the population percentages are the same. And in doing that, building the sampling distribution, I want the best possible estimate of that population difference. So I have 2 samples, and basically the idea is just to go ahead and average those 2 samples. But the samples have different weight in the sense that the sample from the United States is only a sample of 400, whereas from the United Kingdom it's 500. So I need to calculate a weighted average and then incorporate that into my standard error formula. Now I'm going to go off to the side and do that, but all of this following work here is just trying to get that standard error for the differences. So let me go down here at the bottom. There's 2 formulas for this. I need to calculate a pooled percentage, which is basically a weighted average. The sample taken in the United States and the sample taken in the United Kingdom. I'm going to average those 2. And I get 0.293. Now I'm going to plug that into my standard error formula. get 0.0305. So that is the number I need in my hypothesis test. And now I continue with step 3. I'm going to reject h sub 0 if my test statistic z is less than negative 1.96 or z is greater than positive 1.96. Step 4, let's calculate the test statistic. And that is going to be my sample difference, or the 0.111, subtract what I'm testing against, 0, divided by my standard error, and that gives me 3.64. So step 5 is I'm going to reject h sub 0 since 3.64 is greater than 1.96, and conclude that there is a difference. There is a difference in the percent of humor used in TV ads between the United States and the United Kingdom. Now I could also run this with a p-value. My test statistic is 3.64, which is off the chart on the upper end of the distribution. So looking at the table, I would approximate the p-value at 0. In other words, we are so far to the left of 0 with a standard error of 0.0305 that we have very low risk in saying that the null is wrong, and being wrong about that, making a type 1 error. We are very confident that the null is incorrect here. If I use Excel to calculate a p-value, it would give me something like 2.787, and basically what it's saying here, times 10 to the negative 4. So that would be 0.002787, less than 0.05. And that's going to be a doubled value. But again, reject h sub 0.